All right, section 5.2 is exactly like the last section, 5.1, where we are just going to be simplifying using our identities. But in this side, we have an equal sign. Okay. On this, you're going to have to prove that one side equals the other. I'm going to tell you that it's a little bit easier to work with the side that looks more difficult, or the side that has more terms involved, because it's going to be easier to simplify like 4/16 rather than going from 1/3 up to whatever. So in that case, with this one, if I wanted to make sine t cosecant t equal 1, I'm going to work with the side that has more stuff, so I'm going to work on this side. I know that sine t times cosecant t, well, cosecant t is 1 over sine t, so if I replace that in, then I have sine t times 1 over sine t. Well, sine divided by sine is 1, so 1 divided by 1 is 1, and I have 1 equals 1, and that thing works out. Just show me something like check mark or banana or monkey or monkey with banana, or I don't know, something that signifies to me that you know that these two things equal each other, and give me 1 on this side. Tell me that this is 1. Don't just say yes or something. Actually verify it for me. Okay, in this example, the side with more terms is going to be our left side, and it's going to be easier to work with that just because we have more terms. So looking at the left side, I don't see any identities or anything like that, so I'm just going to go ahead and multiply everything out. Okay, so just distribute. 1 times 1 is 1. 1 times negative sine is minus sine theta. Sine theta times 1 is plus sine theta. And sine theta times negative sine theta is negative sine squared theta. Okay, it still equals that other side. I'm not going to rewrite it again. Okay, so now notice that we have minus sine theta plus sine theta. That makes 0. So we're left with 1 minus sine theta, sine squared theta equals whatever. Okay, well, this is looking at your Pythagorean identity. Whoa! Huh. Well, I guess if I say Pythagorean identity, what? It just pops up. Well, I'm not going to say it again, but we're going to use this identity so that we can make 1 minus sine squared. Because if I use this identity, whatever identity this is, and I subtract sine squared theta, so I make it look like cosine squared theta equals 1 minus sine squared theta, then I can substitute in what I know cosine squared theta to be for 1 minus sine squared theta. Because this is the same thing as that, so this must be cosine squared theta equals, well, there we go. There's our connection. Okay, looking at another example. In this one, the side with more terms is going to be my left side. I also have a fraction on the left side. It's way easier to simplify a fraction than it's going to be creating a fraction out of 2 terms that are multiplied together. So in doing that, I want to end up with 1 over sine, because that's cosecant, and I want to end up with 1 over cosine. Remember, you cannot work with the other side. You have to pick one side and work only with that side. So I'm going to choose this side, but I know it's going to have to eventually look like something like this because this is what this side is. So in doing that, I know cosecant squared is 1 over sine squared theta over cotangent is cosine theta over sine theta equals whatever. Okay, well now I am dividing a fraction, so in order to do that, flip your bottom part and multiply top and bottom by that. So sine theta over cosine theta over cosine theta. So that sine divided by sine is 1, cosine divided by cosine is 1, and then also sine divided by sine squared is just going to be 1 sine on bottom, so I will be left with 1 over sine theta times 1 over cosine theta, which is exactly what I wanted. So now that I know this is cosecant theta, and secant theta, that's my answer, and I am simplified as far as I can get. Okay, looking at another example. We have cosecant x minus sine x equals cosine x cotangent x. I'm going to tell you it will be way easier to combine terms than it will to spread them apart using a subtraction and creating a subtraction. So thinking like that, I know cosecant is 1 over sine x, and then I also just have minus sine x over 1 equals whatever. So in order to add fractions, add or subtract fractions, I need to have common denominators. So I'm going to have my common denominator be sine x. So I'm going to multiply this one by sine x over sine x so that I have 1 over sine x minus sine squared over sine x equals whatever that side is. Okay, well then I can combine these two fractions to get 1 minus sine squared x over sine x equals the other side. By our Pythagorean identity, yeah, that's a useful trick. So by this identity, I can move over my sine squared and my sine squared so that I have cosine squared is 1 minus sine squared theta. I have 1 minus sine squared theta in my thing that I'm trying to simplify in my proof. So this is cosine squared x over sine x equals, well, cosine squared is cosine x times cosine x. All of that over sine x. I know that cosine x, cotangent is cosine over sine, so really this is cosine times cosine over sine, which is exactly what I have. So these two terms right here, my cosine divided by sine, that will reduce to cotangent. So I will have cosine x, cotangent x equals, yes, check mark. It's equal to the other side. Okay, this one is straight up your just identities. 1 over tangent is cotangent. 1 over cotangent is tangent. Since addition is commutative, which means kind of like your same community, so you can just move this around. If you really want to, you can say that tan x plus cotangent x equals the other side, or I'm fine with you just stopping right there. But this is just straight up your identities. Also, this one, mainly just knowing your identities. Just knowing that tangent of pi over 2 minus theta is cotangent of theta. So I have cotangent tangent theta equals 1. Well, cotangent is 1 over tangent times tangent equals, oh sorry, I don't usually put that 1 there, do I? Yeah, you can leave it. It doesn't matter if you copy down the other side though, it's the same thing. So then tangent, oh, change colors. Change colors. Change colors. Yeah, because tangent divided by tangent is 1, so we're left with 1 equals, yeah, we got it. Okay, with this one, it's mainly just knowing your identities again. Tangent times cotangent. Well, I know cotangent is 1 over tangent theta, so really this is 1, so I have 1 over cosine theta equals, well, 1 over cosine theta is secant theta, so secant theta equals secant theta. Okay, with this example, first thing that I see is this is a cofunction identity, so I'm just going to leave my first function alone, but this, my cofunction for cosine of pi over 2 minus theta is sine, so really this is sine squared theta equals, well, by the Pythagorean identity, oh how I love saying that, this, cosine squared plus sine squared, is 1, so all I'm going to do is substitute all of this for 1, so that I have 1 equals 1. There we go. Alright, we have another one where we have a cofunction identity. This identity right here, that is just going to be secant. So I have sine theta, secant theta equals tan theta. Secant is 1 over cosine, so I have sine theta times 1 over cosine theta equals tangent, which, yeah, when I multiply these two things together, I'll have sine theta over cosine theta equals tangent. Sine theta over cosine theta, that actually is tangent, so I'll have tangent equals tangent. Good to go. Hopefully this video was helpful for you guys in your homework, especially if you realize what I just did, and happy bananas to you.